Hi, this is Stephen Jones. Welcome to part 2 of our discussion about forecasting. We're going to continue a look at a variety of concepts about how to attempt to forecast what next month's or next year's sales or expenses, resources could be. We had just gotten to the point of what the idea of exponential smoothing is. The idea here is that we are not trying to keep up long-term data out there, but rather just be able to take, say, the last year's worth of data and use that with a smoothing constant, which helps us to account for increases or decreases out there based on, we could look at growth, etc. And this would be a simple formula out there, and I'll show you a more simple one here just a second. But the current forecast is based on the last forecast for a certain period with a smoothing in there and actual demand going on. For example, if you took a look and you estimated February's demand for a certain car model at 142 when you were sitting in January, and then after February was over, in March you noticed that the actual demand was 153, you might say, well, that's a little bit off. I wonder how we could get a little bit closer to it. Well, you would really not just month to month look at it, but you would really actually select a smoothing constant by looking at the mean absolute deviations. You remember that from an earlier lecture, mean absolute deviation, where you look at the actual amount that you were above or below actual sales or actual use, actual money, whatever it is, with your forecast. So being 3 below and 3 above are the same thing in this situation. So you add all those deviations up together and you divide by the number of observations and you get the mean absolute deviation. And so you would look over a certain period of historical data and you would put in a number of different smoothing constants. So let's take a look at one way to do that. And so let's use, in this forecast method here, we will have 175 is the forecast for quarter one. You actually had 180 in sales. So you take what that deviation was by some constant here, and it could be a positive or a negative constant depending upon what you saw the market doing. But you typically would add it in rather than subtract it, but it's possible. So you would take what last month's forecast was and you would add the deviation that you had from it times a smoothing constant. So in this situation, 175 plus 0.1 times 5 gives you 175.5. Now this month you forecasted it was going to be 175.5. This month it actually was 168. So you would take the 175.5 and then you would add 10% of the difference between these two, and you'd come up with this. And you keep going back and forth and doing that, and you'll notice you're off, but potentially you may be off, unless you have very large variations here, you may actually get relatively close, closer to the forecast than you were before. Now, it all depends on what this right here is, what your constant is. You should be looking at historical data to see how far off from month to month you are. So your absolute deviation here for using the 0.1 alpha is about 10.31 in terms of the average, versus if you used a 0.5 forecast, be 12.33. So this would be the best choice for a smoothing constant between these two. But there could be a better one, and you would just have to look at it, look at the data, and see which one would help you to forecast better from 1 month or 1 quarter to the next. Then you have the concept of a trend projection. You remember the trend line that I showed to you before. And so if something is getting larger or smaller over time, that's one thing you'll have to adjust for in your model. And if it's a relatively linear model, whether it's going up or it's going down, if it's a relatively linear model, then you just need to make those adjustments. Hey, sales are falling about 5% every month, so that would tell me next month should be at 95% of what I am this time, and then 95% the next time, and 95%, and then so on and so forth. Seasonal variations come in because of things that happen, and it doesn't, and we're not talking seasonal necessarily because of winter, spring, summer, fall, although that does have an impact on things. It could be seasonal, otherwise growing seasons. It could be sports seasons. You know, there are things that happen from one season to the next that make changes occur. You'll see variations in gasoline price, and the season is not so much hot or cold, but perhaps a holiday season or vacation seasons, etc. And some of that does have to do with actual seasons, people traveling more in the summertime, but they also travel more at holiday times in the fall and the winter time too. So there may be other impacts that go on. And so you would create an index out there which helps you to better predict. You do that based on forecasts and sales demands, and you see where your variations occur on the calendar, and then you change what that's going to be. So you have a monthly demand average out there, and let's say it was 94 as this one shows. But then you add in the seasonal index, which in this case might be a 0.957, and you would multiply that in there and adjust what you consider your forecast to be in the future. Again, you've got to have what the correct monthly demand is, but if these seasonal variations are pretty correct, if you'll notice over several years that up and down flow is pretty consistent, then as long as you get a correct monthly demand here to go against, you should be able to relatively well predict what the next month's, again, expenses, hours of labor, sales could be. And you can use a seasonal index to go with a trend index if you want to do that. So if you know that the trend is that something's getting larger or smaller, and there's seasonal variation with that, you can put those things together and, again, potentially make a better forecast than you would have otherwise. So, how do you control these? Well, we already looked at the mean absolute deviation, which tries to help us determine whether or not our observations and our forecasts are spot on or not. And it's an easy way to do it. There are more complicated ones. We talked about the mean squared error is another one out there if you want to get more statistically close. It also depends on how close do you have to be, because if the mean absolute deviation is a quick and dirty way to get relatively close. And if you don't have to be exact with your forecast, if being in the ballpark is fine, then something easy like the mean absolute deviation is probably your best bet. But if you need to be much more precise with your numbers, then you should use a more complex and accurate means of seeing whether or not you are correct. And some of these, like the running sum of forecast errors, may be one way to do that. Might be helpful. Now, when you're looking at keeping things, on the rails, you can use such things as positive or negative tracking signals. So you can do that graphically, you can do it numerically out there. You can have a formula that trips whenever something gets out of line. And if you find yourself with error above and below the forecast, then you're doing a pretty good job, because you have pretty much stated a good forecast that sometimes a little high, sometimes a little low, but it's staying right there in the center of those observations. If you find that you are consistently under forecasting or over forecasting, and maybe it's a seasonal thing, you might look back at the method that you used to do forecasting. And then you may also simply say, yeah, but again, accuracy, the level of accuracy that you need, may not require that you get really close. And then sometimes it's pretty important. An easy way to do this is just to plot things out. And if you get too far up above your upper control limit or below the lower control limit, then that's when something important happens to you. My dad used to use something similar with investments and the stock market. And if, as time went on, something hit a certain level, that would tell him to buy or to sell. And he wasn't always that successful, but it was something that he looked at and he tracked over time to try to help him keep things going the way that he wanted them to go. Okay, that's the end for this chapter.